Alright, in this video we're going to take a look at how the understanding by design approach to unit planning can be used with the next generation science standards. So first let's take a look at the a design template for understanding by design. So the first step really is to set the learning goals. So what do we want students to understand, know, and be able to do at the end of instruction? So by understand we mean what are the big ideas or concepts that students should understand. When we talk about know, these are the smaller ideas, so vocabulary, formula, processes that are important for students to know at the end of instruction. In this section, we're looking at the skills or processes that students should be able to perform after instruction. So what should they be able to do? And finally, as we think about our learning goals for students, we have the essential question. So what big questions can we ask that allow students to connect course content between units? The next step in understanding by design, after we have the learning goals set, is to look at how we'll know if our students actually can understand and do these types of things. So the determining what the assessment is. Now let's take a look at one of the standards pages. So in this case, we're looking at the third grade forces and interactions topic. So here you'll see there's a number of performance expectations up at the top, and then we have the foundations boxes with the practices, the core ideas, and the cross-cutting concepts. So let's start by looking at the performance expectations. So really a performance expectation is what guides our assessment. It describes what students can demonstrate at the end of instruction. So for this topic, there's 4 different performance expectations, and as we read through these, we can look, and maybe some of them will work well together. So you could combine those into an instructional unit, or you may want to take and make a smaller instructional sequence just around one. So let's look at how we can apply understanding by design using this first performance expectation. So that students should be able to plan and conduct an investigation to provide evidence of the effects of balanced and unbalanced forces on the motion of an object. So since this is a performance expectation, it's guiding our assessment, so it makes sense for us to start at stage 2 and put this performance expectation in as how we're going to what we're going to assess for our students. At this point, it might be useful to also think about an activity that we might use to actually turn this performance expectation into a performance assessment, and we can really provide more details for that later. So one possible activity would be to give students a variety of materials and have them design and carry out an investigation that could show the effects of balanced and unbalanced forces on an object, and then have them communicate their results through writings and drawings. So again, it's connected directly to that performance expectation that we drew from the next generation science standards. So now that we have the performance expectations and that assessment, what we really need to do is think about what our learning goals are. So as you look at the foundations boxes in NGSS, those really describe, or at least the disciplinary core idea foundation box really defines what our students should understand at the end of instruction. And we can also look at the disciplinary core ideas to help guide some of the vocabulary that we might want our students to understand. We could also, of course, pull vocabulary from other parts, so from the cross-cutting concepts and the practices. So if we go back to our template, it might look something like this. So that disciplinary core idea is really the big idea or the concept that we want our students to understand. So in this case, we want students to understand that each force acts on one particular object and has both strength and a direction. An object at rest typically has multiple forces acting on it, but they add to give 0 net force on that object. So balanced forces. And forces that do not sum to 0, unbalanced forces, can cause changes in the object's speed or direction of motion. And we know with third graders we want to do this conceptually, but not quantitatively. So they don't have to use the mathematics of Newton's second law, but they should be able to understand it qualitatively. We also can look at what we might want students to know. So here we can pick up some vocabulary. So if you look at that disciplinary core idea, it seems like students should have an understanding of what force is. So the vocabulary force, motion, balanced forces, and unbalanced forces. Next, we can go to the Science and Engineering Practices foundation box. So here we know that we want students to use multiple practices, so they'll be using more than just these two, but these are the two that we really want to focus on as far as what we make explicit in our instruction and what we're going to assess. So in this case, we'll put that in the do box. So students should be able to ask questions related to force and motion, they should be able to plan an investigation, and they should be able to communicate the results of an investigation. And as you look at these, I think you can pretty clearly see how our performance expectation will allow us to assess what students understand, what they know, so the vocabulary, and also what our students are able to do. Now finally, we can look at this cross-cutting concepts foundation box. So cross-cutting concepts are those big underlying concepts that cut across all the different disciplines in science. So they're great for making connections between different content. So I think it's really kind of exciting to be able to use these cross-cutting concepts as essential questions that connect all of the content that we're using throughout the school year. So in this case, maybe we can have two essential questions. So one of those essential questions can come straight from the disciplinary core idea. So what are forces and how do they affect motion? That seems to really kind of guide this entire unit. And then a second essential question, which is focused on that cross-cutting concept. So can patterns be used to make future predictions of motion? Is something that'll cut across not just this forces unit, but other instructional sequences that we'll have in third grade related to forces in motion. So once we have those, again, we can take a little bit more of a look at how we're going to assess our students. So that second step in planning by using understanding by design. So again, we have a performance expectation about planning and conducting an investigation to provide evidence of balanced and unbalanced forces. So our performance assessment, so the task that students will do is to actually have them plan and carry out an investigation to do this. But that's not the only thing that we might want to do in terms of assessing our students. So we are going to want to know if students understand the vocabulary. So we might, after students learn the vocabulary, have a quiz to see if they actually understand it. We could do some focused listing. So give them some phrases and have them determine if it's a force or a motion. We can give them images of a book sitting on a table, for example, and have them identify the forces that are acting on that object. And then we can also give them scenarios where they can look and see how forces acting on an object might affect motion. So, for example, if we show an image of a ball rolling across the floor and a person about to kick it in kind of perpendicular to its path, then they can match that to what they think would happen to the motion. So it's again a way to assess if they understand balanced and unbalanced forces in this case. Once we have that part ready, so once we know our learning goals and once we know how we're going to assess that, then we can get into starting to plan our activities.